Can I put objects in an array? How do I send a message to an object in an array? How do I copy an array of objects? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is video 44 in the Introductory Programming in Java full course and the 5th video of the final lesson, Lesson 7, Arrays and Array Lists in Java. So far we've looked at arrays and methods, reading into an array from a file, and searching and sorting algorithms. In all of those examples, our arrays were filled with primitive data types. Today we're going to look at arrays of objects. Let's get right into it. Here I have the die class from an earlier video with the Java doc removed so we can focus on the code. A die object represents a single die. When the object is created, either the number of sides is specified as a parameter or the die has a default of 6 sides if the noarg constructor is invoked. The die can be rolled with the roll message, and it can return its value with the getValue message. This is our prior dice program that creates 4 die objects and sends them each the getValue message, printing the result, then rolls them, then sends them the getValue message again and prints the result. And if I run it, you can see the result of the message to each D6 before and after, and then the D12 before and after, and then the D20 before and after. Each time I run it, we see mostly different numbers, as the die object uses the random class to generate its new side when it receives the roll message. Suppose we need to create 10 die objects that will be used throughout an application. There are games that use many dice, but the application isn't important. We're going to focus on arrays of objects, and this is a relatively simple class to work with. Because we have so many die objects, it makes sense to store them in an array. We can iterate over the array in a loop, sending messages to the objects such as roll and getValue. This program is called simpledieArray.java. Let's look at the syntax of creating an array of objects and sending those objects messages. We begin by declaring the array variable called diceArray on line 7. Remember that the data type for an array is the data type of the elements of the array, followed by open and close square brackets. If an array is going to store an object type, we put the class name followed by the square brackets. Therefore, our variable declaration is die, open close square brackets, diceArray. Now that is just the variable declaration. It tells Java that diceArray is an array of die objects. This allows Java to check our program for syntax errors. To create the array, we must use the new keyword. Here on line 10, we have diceArray equals new die 10. This syntax should be familiar. It's how we've created our arrays all along. Variable name equals new, element data type, open square bracket, size of the array, close square bracket. The only part that might feel unfamiliar is the data type, die, because that's our own programmer-defined data type. Once this code has executed, we have a reference on the call stack, diceArray, referencing an array object in the heap. I'm also going to show a more abstract illustration that might be helpful for visualizing the data structure, a series of continuous boxes with indices above them. When an array is created, its elements are given default values, just as with any object type. When the element type of an array is an object type, the default value is null. Null is a literal value in Java that means there is no object at the reference. So diceArray after line 10 is an array of 10 null references. The next code in the program is a loop from lines 13 to 15 that creates 10 die objects and stores them in the array. To understand this code, remember that variable name subindex is a variable of the array element type. So diceArray sub 0 is a die variable. Before our loop, that variable reference is null. The loop iterates over the array with for I equals 0, I less than diceArray.length, I++. The first time through the loop, I is 0, so diceArray sub I references the die variable at index 0 in the array. Inside the loop, we have the line of code diceArray sub I equals new die. Let's break that down. Assignment statements execute right side first. On the right, we have new die. This creates a new die object in memory and invokes the noarg constructor, which sets the die's num sides to 6 and then sends it the roll message, which gives the die a random value between 1 and 6. Let's say it gets the value 4. I've drawn that object in the heap. Now, that object's reference will be assigned to the variable on the left of the assignment statement, which is dice array sub 0. So I'll put that reference in dice array sub 0. In my more abstract drawing, I'm going to put an object diagram for the object in the first box in the array, showing the two fields and their values. The loop continues for each element of the array, creating and initializing a new die object and storing the reference in the next location in dice array. I don't have space to show all of the objects, so I'm eliding my drawings. Once the loop is finished executing, our dice array contains 10 die objects. Before we continue, let's review the allocation of memory in the heap that got us here. We had to first create the array with the new keyword. That's here on line 10. Then, for each element of the array, we had to also use the new keyword because those elements are also objects. That's here in our loop on line 14. That line executes 10 times, once each time through the loop for each element in the array. The next block of code in this program is also a loop. This loop iterates over dice array, sending the getValue message to each object and then printing the value that's returned. The syntax for sending a message to an object in an array can be a little intimidating, so let's break down an example. Line 20 is int value equals dice array sub I dot getValue. This sends the getValue message to the element at index 0 in dice array and stores the result in the variable value. So on the left, we have int value equals, declaring an integer variable called value, and assigning to it the value of the expression on the right of the assignment operator. On the right, we're sending a message to an object in an array. We start with dice array sub I, which is the element at index 0 in dice array the first time through the loop. That element is a die object. We can therefore send it any message we can send a die object with the dot notation, so dot getValue. If that syntax is uncomfortable, you can break it into pieces until it feels more natural. For example, we can write die current die equals dice array sub I, and then int value equals current die dot getValue. In the first step, we assign a variable reference to the die object. In the second step, we send the getValue message to the variable reference and assign the result to value. You can see from the illustration of the stack and the heap that current die and dice array sub 0 both reference the same die object in memory. The next time through the loop, current die will reference the element at index 1, etc. until the loop is finished executing and current die references dice array sub 9. In the loop, we then send the roll message using the same syntax. Since roll doesn't return a value, we don't need to assign the result of the call to a variable. After that, we send the getValue message again, but this time rather than assigning the result to a variable, I'm printing it directly. I think the trickiest thing here is getting used to the idea that what is at a specific array index is an object we can send a message to, and then getting comfortable with the syntax. That's a lot of punctuation on each line. Remember that you can break it into pieces while you're learning. But if you're faced with a line of code, like line 24, just take it one piece at a time. Dice array sub I is a die object at index I in the array. Dot getValue invokes the getValue method on that die object, which returns an integer. And we can then print that integer. Let's now review some array operations, but with arrays of objects rather than arrays of primitives. We can use our same variable roles and algorithms to sum values that we obtain from objects or find a most wanted value. Let's look at an accumulator pattern using our array of die objects. We'll average the values of the dice. I'll write this below the existing code. I'll declare an integer variable called total and initialize it to 0. This will be our accumulator for adding the die values. We'll write a loop to iterate over the array. For int I equals 0, I less than dice array.length, I++. And then inside the loop, I want to add up the die values, so I'll need to send the getValue message to each die and add it to total. Total plus equals dice array sub I Remember, that's the next die object in the array, so I can send it a message, .getValue. That's it. This loop sends the getValue message to each die in the array and adds the returned value to total. After the loop, I can calculate and print an average in one step. System out printf, the average of the dice is %.1f/n, double total divided by diceArray.length. I urge you to take a moment and find the largest die value in the array, or count the number of die objects that have a value of 6, for example, to practice with our familiar algorithms, but operating on an array of objects. Let's review passing arrays to methods and copying arrays, but this time with arrays of objects. Copying arrays is more complicated with arrays of objects. This program is called diceArrayMethods.java, and it's very similar in functionality to our last program, except this program has two methods, a makeDice method and a rollDice method. These methods do some of the work of the program, so the main method is simpler and easier to read. In the main method, we have diceArray equals makeDice10. We are assigning the result of this method to our diceArray variable, so this method returns an array of die objects. If we look at the method header, we can see the return type is die open close square bracket, an array of die objects. This method takes a variable as a parameter, which is the size of the array, numDice. Inside the method, we create a new array of die objects using the new keyword and the numDice parameter as the size. We then iterate over the array and create and store a new die for each element in the array. We then return the array. This is hopefully familiar now. The only thing that might be a little strange is the return type, an array of our programmer-defined type die, so die open close square brackets. In main, we then invoke the rollDice method and we pass our new array as a parameter. So up in rollDice, we can see a parameter variable of type array of die open close square bracket. We then send the roll message to each die in the array. This again should be familiar, with only the parameter type being a little new. Let's review what is happening when we invoke these methods. When we invoke makeDice with the line die open close square bracket diceArray equals makeDice10, we have an assignment statement which evaluates right to left. So the method call happens first. A frame is placed on the call stack for makeDice with the parameter 10 and the local variable dice. I'm also going to include the local variable I, which is in scope in the for loop only. The value 10 is copied into the parameter variable numDice when we invoke the method. The first line of the method is die dice equals new die numDice. This creates space in the heap for the array, with each element initialized to null. We then have the loop that iterates over the array and creates new die objects for each element in the array. So after this loop is finished executing, we'll have an array of die objects. Again, I'll elide the illustration to save space. The reference to that array is then returned. Back where we invoke the line, the reference is assigned to diceArray. So diceArray now points to the array created in makeDice. We then invoke rollDice and pass this reference. The reference to the array is passed up to rollDice, so rollDice has access to the same array of die objects that we have in main. In this method, each die is sent the roll message, giving each die a random value between 1 and 6. When we return from this method, the values in the die objects in the array have most likely changed. In a prior video, we made a copy of an array to pass to a method so that the original array wouldn't be changed. But that was an array of primitive data, an integer, double char, or Boolean type. This is an array of objects, so this is different. I'll write some code to copy diceArray before we pass it to rollDice. I'll write die copy equals new die diceArray.length to make a new array object the same size as diceArray. And then for int I equals 0, I less than diceArray.length I++, copy sub I equals diceArray sub I. Let's look at what that does. We first make a whole new array of die objects in the heap, and it will be initialized to null values. So far, so good. But in our loop, we copy our die object references into the copy array. Now the copy array is completely new, but it's still referencing the same objects as our original array. There are only 10 die objects in memory, and they're each being referenced by the 2 different arrays. So if we pass either array to roll dice, the die objects will be changed for both arrays, since both arrays reference the same die objects. This is called a shallow copy. We have copied the array, but we haven't copied the objects in the array. A shallow copy works fine for primitive values, but for objects, because the reference to the object is copied and not the object itself, a shallow copy means we're still leaving our objects vulnerable to being changed. What we need is a deep copy. Each time through our loop, rather than assigning the reference at diceArray sub I to copy sub I, we want to make a copy of the object at diceArray sub I and assign that reference to copy sub I. The way to do this is to write a copy constructor for our die object. We talked about copy constructors in an earlier video in the lesson on objects and classes. A copy constructor takes another object of the same class as a parameter, and it copies all of that object's fields into its own. So for die, our copy constructor will look like public die, and I'll call the parameter toCopy, so die toCopy. And then within the constructor, this.numSides equals toCopy.numSides, and this.value equals toCopy.value. When this constructor is invoked, I will have an object with duplicate data to the original, but it will be a separate object. Back in the loop, I'll write copy sub I equals new die, diceArray sub I. So what is happening there? On the right side of the assignment statement, I'm using the new keyword and creating a new die object, but I'm passing the die object at index I in diceArray to the constructor. Java will match this method signature to the copy constructor signature and invoke the copy constructor. The resulting die object will be stored in the new array, copy, at index I. Once this code is finished executing, I'll have a complete copy of the array, including the objects in the array. Whatever I do with the copy array, it will have no impact on the original diceArray array. In this video, we looked at how to create an array of our own programmer-defined data type. Because an array is an object, and the values we're putting in the array are also objects, we'll use the new keyword to create the array, and then we'll use it again for each object we put in the array. The syntax of sending messages to objects in an array can feel a little daunting because we first index into the array with square brackets and then send a message with the dot notation. There is a lot of punctuation. You can separate this out into 2 steps, assigning the object into a variable and then sending a message to the object variable until the syntax feels more intuitive. We looked at how to total values obtained from array objects in a loop, and we learned how to make a deep copy of an array of objects, a copy that not only copies the array, but also copies the objects in the array, so that the copy is completely independent from the original array. I hope you found this video interesting and helpful. As usual, I've included some auto-graded exercises in the description of this video so you can practice with this code, and the video code is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.